Okay, so the today's topic is system design of WhatsApp. Okay, so hello guys, this is Jyoti with us and Vishal, who is preparing for the system design. So let's start with the system design. I'll just present my, I mean, architecture diagram to the lucid chart, and we'll also have that doc running where I can write down some notes.
Sure,
Okay,
let's begin.
so let me just share my screen. Can you see? Okay, so I'll just
Yes.
start with the basics. You know, what are the requirements, and then let's just write few of the requirements, non-functional requirement, and then we'll go to the high-level system design architecture. So functional requirement, I mean, user. I mean, there's a many other features like native features like a login, logout. I think I'm not writing those functional requirement. I'm just going straight to the what is the core of that WhatsApp, that is like in a one-on-one chat. So user can do one-on-one chats, and users can do group chats. Okay, and user can upload media files. User
Mm,
can do uh, like a uh, user can do upload a media files, group chats and chats, and what else, I think, yeah. So and user can see that blue tick.
Last scene.
Yes, blue last seen, blue ticks, etc. I
Okay.
mean the single tick for delivery, single tick for sending message. User can see double tick for delivery of message, and user can see blue tick once it is seen by other user. Okay, so let's keep these many functional requirements, and we can extend the other requirements if required. We can extend on the top of it. So I'm just keeping the template as in like we are doing the system design interview as it being done in the company's interview. So let's write some non-functional requirement. Okay, so the non-functional requirements are like a system should be highly scalable, right? System should be highly available, like a uptime should be 99%. Is system should be reliable. It, like it should be able to keep. Uh, it should be able to uh, maintain the user data properly, right? And system should have a very low latency. System should be system should have low latency for real time read and writes. And in the last system, system seems like a read heavy system. I mean it's a both read heavy and write heavy. Okay, so
But what consistency? It should be eventual or highly consistent.
I mean consistency. I mean, we'll have to see where we are checking this consistency. See, consistency, we cannot say this term in general. Key consistency should be applied to all the feature of that WhatsApp.
Okay.
Yeah, right. There are the some consistency that we can maintain, like as in like the ordering of the message should be consistent for the user,
Okay.
right? So because the ordering of the message should not be inappropriate, or it shouldn't be inconsistent, otherwise the user experience will be very bad, right? How it would be if some of the messages that you have seen, some of them has appeared first and which was sent later on. So if they are being mixed up, then it will be very inconsistent user behavior. So we can keep that consistency with respect to that consistency high. So system should maintain the order of messages. I think that's very important. Okay, and yeah. So let's. We have covered the non-functional requirement. I'm not going with the app capacity estimation as of now, but we can go ahead later on once we cover through the high-level system design. High-level system design. And then in the end we'll also go through the with API design, and more important the database design, that is the more important. Okay, so let's start with that high level system design architectural. Okay, so I'm going to start and create the block diagram here. So let's start with so we'll have some API gateway. Okay, and uh, user will come from here. Client one, and so there is a client. There can be the multiple clients. I mean, the WhatsApp can have a billions of the clients be connected. So when I say client, it is nothing but the WhatsApp client that we are running on our Android phones or Apple phone, right? So I'm just talking about those are the clients here, right? And they can talk. Uh, so now I'm just going. So first thing is that what are the protocol that we're going to choose? The client. So there is a three ways that the client can be connected to the backend services. Okay, one is like one is like an HTTP connection, one is like an a WebSocket connection, and one is like an a long pole, right? That is also an HTTP connection, but which have a higher time compared to the normal HTTP connections, right? But in the world of I mean, where does we need a WebSocket connection? So HTTP connection are the request response model, right? Is it's just like a transactional model. You have a query, you ask that, you get a response, your transaction is complete. That's how. But the WebSocket connection are the more persistent connections, right? Where the connection is not being broken, even you have got the response from them, because there's a response from the server, there's an ask from the client. So both of the server and client can communicate in each other, and in the real time world where we have been client and server been talking very high very frequently. So that is where the persistent connection is preferred, and that is and the WebSocket connection is one of the provide interfaces to provide create a persistent connection, right? So we'll go with the persistent connection is nothing but a WebSocket connection. Okay, because both of the I mean client and both the server can communicate to the each other at a time. right? And in the real world, like in a games, where the high streaming has been happening from both of the side, a lot of the data is being exchanged from both of the side. That is where WebSocket connection or persistent connection is really required, because if you're gonna create a new connection or HTTP connection every few minutes, it's gonna be very high latency on your system. So hence we preferred having a one persistent connection and let the data being flowing from both of the side at the same point of the time. Okay, so that's why, so we will be using the WebSocket connection. Now I'll just create a one of the thing is routing service. So yeah,
So the
we,
connection you mentioned is maintained between client one and API gateway, right?
yes, yes,
WebSocket connection. Okay.
exactly. So because WebSocket connection, it has a two ends, and both of the end it connected using a IP address and port. So it's a machine's property. So client one, anybody, any one of the client has to go through the API gateway. It will make a connection to API gateway. API gateway behind the scene will create a connection to the backend services, right? And because on the back end behind the API gateway, there can be n number of services, and all of those servers may have their different IP address and port, and which is doesn't seems reliable ki client to know every IP address and port to connect to the their backend services. So hence we need some common interfaces which ensure, provide us one of the one IP address, but at least fixed IP address so that we can communicate through it. So that is where API
Okay.
gateway and load balancers are generally play a very good role.
Right.
Okay, so let me duplicate. So there can be the n number of socket handlers here. My purpose is to okay, and let me just create Redis. So I'm gonna use a Redis cluster. I'll explain what is the purpose of each of them, and they're gonna be the request handler. So how handler one. Okay, now so all of those client will be connected to the WebSocket handlers, uh, and then a WebSocket handler is like an which is whose responsibility is mainly to let the client to be connected through them. And the whenever the any client connected to the WebSocket handler, WebSocket handler update into the Redis cluster saying, "Hey, the client one is connected to the socket handler one." Is like in a mapping being stored into the Redis cluster. It will be later on useful when there is a communication from the server side to send back to the client. That is where we would need this mapping to be stored so that we can find it out which machine or socket, which socket handler the client are being connected, right? So here it will be a Redis clusters, and the socket one handler, whenever there can be n number of client be connected on the socket handler, each of the socket handler, and there can be, these are the horizontally scalable socket handler. If we, let's say we have a 10 million clients being connected at the same time, and each socket handler can handle 1 million clients, so we will be having a 10 such machines, right? and uh, and whenever the client new socket connection is being created, it means the client one is connect client is connecting to the socket handler. That is where the first responsibility is to update into the Redis cluster saying, hey, create the mapping. The client one is connected to the socket handler one, client 2 is connected to the socket handler 2, and just like that, so that later on when there is a communication from server side, it can be figure it out which machine the client is connected to. Okay, so now
What is the exact job of the socket handler? Can't API gateway directly put in the port number of client one into Redis cluster?
no, the point is ki uh, API gateway responsibility is to talk to the backend services, right? We may do that responsibility, but if let's say we have a millions of our clients, and if we have to scale the number of our clients, we don't want to keep that responsibility to on API gateway. We want to have that responsibility being on the some of the servers which are meant to handle for such things like in a WebSocket handler, and we should be able to scale them. If tomorrow we have a lot of our clients, we'll have to scale API gateway as well also. But there are some API gateway and Nginx API gateway which can handle millions of the socket connection. But we don't need to. The point we'll have to keep the point of separations, here the socket handler is meant for the server. We wanted to independently scale them. We don't want to scale the API gateway at the same point of the time, and we might not need a API gateway to scale, but we might need to scale the socket handler. But if we keep the responsibility, if we don't give the separation of concerns divided properly, we'll eventually being into that monolithic system where we'll have to scale everything for any of the things, right? So I don't want to keep that responsibility on API gateway. So that is where we have chosen the socket handler, because it consumes some amount of memory, right? But that's a good question, because any client is connected to the API gateway, and API gateway connect to the backend services, right? So now let's just move ahead. We have updated the mapping into the Redis cluster. You may ask me, there can be the n number of Redis cluster machine, and what are the partitioning strategy that I have choose. Let me just complete the entire diagram, then we will talk the entire flow. Okay, and
Right.
now what we'll do, so these guy will talk to them, or I think it's not okay. Just a minute. So here we can have a some of the services. Let's say we have a chat server. There can be the multiple chat servers here. Okay, and there can be the media media server as well also, which is meant to store for handling the images and videos. Media server. And all these services component are the horizontally scalable. We can spawn n number of such instances basis on the load. So these are the horizontally scalables. Okay, and we may have media and then we may have I think, yeah, that's much. So media server one, and let's say I'm just drawing the two instances of them, but there can be more also, right? Now the socket handlers can be connected, let's say, uh, so there will be obviously for each of these type of services there will be load balancer behind them. I'm not drawing those things, but whenever there is a instance more than a one, assume because there will be a load balancer behind them, because otherwise every machine has to know, has to discover the IP address and port of the each individual machine. So there will be a load balancer behind them, right? So socket handler one is connecting to the chat server one, and similarly, socket handler can connect to the. I'm okay. Let's just not draw this. So let's say, yeah. So yeah, now what we have to do, okay, so there's a message being received on the chat server can store into the messages into the database. Let's say we have a NoSQL uh, NoSQL database, something like Cassandra is a key value databases and highly suited for these kind of purpose. And by the way, when WhatsApp is started, it is started using the Cassandra first, and then later then they have moved to the new other databases. So Cassandra is highly suited for the very frequent read write kind of an system. And we can also use Amazon DynamoDB, that is also meant for these kind of purpose, like in a high throughput of writes. Okay, so chat server will store the chat into the DynamoDB, and the media server will store that files something on the object storage, like in a S3 or data lake. Uh, let's say it is an S3 or Azure Azure. You can call it an or any other object storage, or you can call it file storage. Okay, so files and any kind of any kind of file, kind of a video and images are supposed to be stored on this, as a file on the S3. Or you may ask me why I have not chosen the NoSQL DB to store it, uh, to store such thing, but it's NoSQL DB is not meant for storing that uh, something like in a files. Okay, so
Why aren't
now,
we using SQLDB for storing messages? Like we are
okay,
storing in key value terms only, right?
that's a good question. Why we are not using a SQL system here? See, there's a few things. SQL storage is not by default horizontally scalable. You will have to create a number of an instances, and you will have to decide yourself. It doesn't support a horizontal partitioning by their own as well, right? You will have to set up that. You can do that, sharding and all, but NoSQL storage come with this feature out of in a box. You don't have to think about you just have to define your partition key, and it will take care of your keeping the partitions on the different nodes. But see, in the case of a SQL storage, you will have to do that job by yourself. You'll have to set up that infra, and you will have to ensure ki what shard is meant for that, for which partitions and all. So that support is not there. Apart from that, there is other thing as well also. Uh, SQL storage is a kind of a B plus tree storage instance, right? That is where, and it the write is not that efficient compared to the NoSQL storage, which use a LSM based storage engines. LSM storage engine where the write happens in the order of one append manner, right? And in the case of the SQL storage in the B plus tree, the write has to be updated. The write happens in place, right? And that is where it complexity also goes to the order of log n, right? So which is not effective for our use case when there is a very high write throughput, right? And here uh, also there's some cases that there's a read efficiency is good into the SQL storage, but given the way we partition the data properly, and if using the partition we can fetch the entire set of messages in the given frame of time, so throughput will effectively overrule that read latency of the SQL storage. Okay, so NoSQL storage is a good in these case purpose. Now let me just okay, let me, I need a Kafka here. I'll explain for what purpose. Kafka, and then there could be the fan out service, and we may have a something like fan out service. This is like a group service. fan out may ask, and okay, so one fan out can talk to the request handlers to know. Okay, now let's just talk about the simple use case. The client one is talking to the client B, right? So client one is connected to the one of the socket handler. Let's say the socket handler one, socket handler update into the Redis cluster. First time the connection is created. Hey, I'm connected. Client one is connected into the socket handler one, right? So here the Redis, we are using the Redis cluster. There will be the multiple instances of the Redis node, right? So we'll have to use a proper partitioning strategy here, right? And I think the partitioning key, it should be the client ID, the user ID here, right? Why? Because every communication is being triggered by the user ID, which with respect to the user only. So if the request handler also come and has to send the communication back to the client, it means it know that which client it has to send the communication. So it can go to that particular partition and figure it out which machine the client one is connected to send back the communication, right? So hence we need to use a partition key which is be proper. I mean, we'll have to choose the partition key very, very uh, properly. Otherwise, if you don't choose the partitioning key properly, you may not be able to scale your system well, right? You may, I mean, I may have choose a partition key here, a machine ID itself also, let's say socket handler ID. But how is that helpful for me? Can I, my request, the data access pattern is being always using the user ID only, right? So hence I've chosen the user ID as a partition key to, so given the socket handler one will talk to the using the user ID, applying the consistent hashing, and will go to the particular instance of the Redis cluster node, and will update on that node key. Client one is connected to the socket handler one, and client two connected to the socket handler two, and like on, right? And so the socket handler one will update the first time into the Redis cluster, and then it will talk to the chat server. Let's say the chat server, there is a message to be sent, chat server, it communicate to the chat server. And you may ask, if the protocol will be used internally could be very different, it like in a WebSocket connection, because it will also internally be using persistent connections, right? It could be for an internal communication gRPC protocol, right? This is also nothing but kind of TCP socket connection, but being with a different protocol on the top of it, right? But it should be persistent connection only, right? And gRPC also is one of the persistent connection, but one of the very lightweight connection being heavily used for internal communication of that services, right? So the message is sent to the chat server one. The chat server one will update into the I'll talk about the schema design of the NoSQL schema design. What is the data model here? How many tables are there, what tables are there, and how the schema is look like there, and what are the partitioning strategy that we are going to use. Okay, so so chat server one will write the messages into the, let's say, conversation table. There's a conversation message table, and then once the message is being persisted, then there is a using the CDC pattern. If you guys know that there is a change data capture pattern. Change data capture, whenever there is a change into the on all those tables, it will capture those messages and will send to the Kafka, right? And in the Kafka, in the one of the partition of the Kafka is like in a message broker, which is a very is a kind of very reliable. It handle a lot of an amount of the data that is in transit. When I say transit, uh, there are the producer which produce the data, and there will be a consumer in will consume the data. So it just provide the ability to reliable transit. You can say reliable transit, right? So now there will be a fan out service which will be connected to the Kafka. As a consumer, it will read from all the partition of the Kafka, and let's say it receive the message from the client one. So what it will does, it will figure it out whether given that message that is being sent using it will ask the group service, hey, uh, who all are the members of that conversation that client one has sent it. Let's say if it is a one-on-one, it will figure out the client two details using the group service, and it will send the message to the request handler 2. Request handler 2 will talk to the Redis cluster and figure it out the if the client 2 is connected to them or not, right? If the client 2 is connected them or not. If the client 2 is connected, it will from the Redis cluster it will figure out which socket handler it is connected to, and using that from that socket handler it will make a communication to that machine and will send back that message to the client too, right? So that is where I needed a user ID as a partition key in the Redis cluster, because when the request will receive at the request handler, they will also fetch the data using the client ID only, because they have the client ID. So if it being so you it will ask the Redis cluster, go to the particular instance where the client ID client 2 is connected to which machine, using the client ID 2 partition key, will go to that particular instance, will figure it out which socket handler instance it is connected to, and will make a they will have also connections between the socket handler and request handler, and the request handler will figure it out which machine it is, and then will send back the communication to the client too, right? So that's how that the flow is being when there is a chat message, client 1 is sending the chat message to the client 2, right?
In this case, why group service is quoted is talking to no SQL database? Like for
Okay,
fanout service will deliver the message to all the recipients, right? Intended
right,
recipients.
right.
So, and group service will tell fanout service which all recipients are there. Is that so?
So basically, I'll talk about that. So there is a one-on-one messages, like we are talking one-on-one in the WhatsApp. There is a group messages as well. Also, there is a thousand of the person being present in that group, and if I have sent the message in that group, it has to be delivered to the all of that group participant, right? So group service is nothing but it's like in a service, and it will talk to that. There will be a table in that NoSQL database. From using that, it will figure it out what all participant is a part of that group, right? And it will figure it out all of their client IDs. Okay, it will figure out all of their user client ID, could be their phone number as well also, and could be any random unique ID assigned to them, right? So let's say group one has a, if it is a one-on-one, group service may return only one participant, but if it is a multiple, a group service will return all the participant of the group, right? there's there's nothing much difference, group versus one-on-one. It's just like in a two member versus a three member. So think from that perspective, if it is a two member group versus a three member group.
But then won't the Kafka will be Kafka will contain. So Kafka will contain only the message,
Right, in transit.
not
Like if I have to
the
send the telegram to his to your place, right? So what I'll do, I will ask that I will deliver that message, go to the nearest post office, and will do that, and then they will take the responsibility of transiting to your place as a reliable manner, right? So the
okay.
goods being transit in the as a reliability, the Kafka is in the software system that provide as a notion of uh, doing the I mean delivering the thing in the transit as a reliable, right? So it doesn't get lost.
So when the socket handler is talking to chat server 1 and chat server 1 is writing to DB,
Hmm.
won't it be a speed mismatch, like socket handler will be sending message at a rapid pace, then chat server 1 will be writing to DB? So shouldn't we place a message broker there also?
I didn't get your point. Speak again.
So this chat server is receiving messages from socket handler,
Right,
right? And then adding this into NoSQL DB. So
right,
writing into DB will be a slow process, right? As compared to reading from socket handler.
right. Writing to the DB, but that's why it is a
There won't be
append.
there will be a speed mismatch, right? Between like chat server one will be overloaded with the messages from socket handler one. Like
No, so
clients will be continuously sending
no, so
messages.
there will be a n. So if there is a load, there is a n number of a search servers, and there will be a load balancer behind of it. The load balancer will ensure ki every new connections. I mean, it will ensure that doing the load balancing across a number of chat server. So, but uh, let's say
But this is a persistent connection, right? Between socket handler one and chat server one.
no,
Or
it
is
will
it a stateless kind of thing?
it will be a persistent connection, but again these all connection will go as in like there will be a load balancer behind the chat server. Again socket handler will connect to the load balancer, and the load balancer will connect to
Okay.
the chat server one, but these will be a sticky session because once the connection is being made, until unless you you connect disconnect your internet, or till that point of the time, it will be a same connection, and it will be a to the same machine as well
Okay.
also, right? So it's
So
like an
but
sticky session.
they won't be maintaining any state like I am receiving from client one or something like that. It will be random, right? As
Right,
per load
right,
only.
right.
Got it.
Because that it's not like that kind of an state. Here we have also not stored any state. We have updated it with the Redis cluster. So these are the also a stateless node only, right?
Okay.
These are not, I mean, if I would have kept those information, which I'm storing into the Redis cluster in their memory itself, then it would have, stateful machines. But
Right.
I didn't do that way because if that mapping is being lost, we are going, won't be
Hmm.
able to send that message back to the client. So we are not
Right.
saving state in their machine itself. Hence, these machines are the stateless. Even though these chat servers are also stateless, we are not storing any state. It's just that in transit, it will come and store the message into the NoSQL DB. Okay.
Okay.
Now, these connections has to be the socket handler will have a connection to chat server one. It may have a connection to the chat server two. Right.
Okay.
You may ask me, I would have connected the all of those clients directly to the chat server rather than having these routing service in between, right?
Right.
There's a reason behind I haven't do then that way because if I would have connected the clients directly to the chat server once, rather having this routing service, it would have very high load on the chat server, and it would be very tedious task to scale the chat server as well also because uh, the client when the client is connected to the socket handler, it consuming memory on them. So one socket a socket handler machine could be of 16 GB RAM, and some configuration it can support only maximum for some x number of on a client at any point of the time, or you can say any persistent connection, socket connection. But if I would have given this responsibility to the chat server itself only, then it would have caused a lot of impact on that, processing time for the message itself also. Hence, I wanted to keep that separate so that we can independently scale the chat server and socket handler. It may be possible there is a 10,000 socket handler, but only 10 of the chat server at any point of the time, right?
Okay,
Uh,
so I'll explain again.
I'll explain why the socket handler is needed, why I have not redirected my connections, directly let the client to connect it to the chat servers, right? So obviously I wanted to keep the separation of concerns here properly because we might want to scale them independently as in when there is needed. It might be possible if I would have connected the client directly to the chat servers, so I mean the chat server would have become loaded only because the clients there's a lot of number of a connection is being made to them, right? And because of that, will the load is very high on the chat server, we would have to scale them, right? But here we can have a separate machines or separate instances to handle such a socket connections. As a socket, I mean, it could be very uh, may not be very costly machine as well also, just for the purpose of the socket handlers, where we have a bare metal machines and RAM being of 16 GB. So for that purpose, I kept it separate. So because we may have a 50 or 100 or 1000 socket handler machine at the same point of the time, but we might not need, there's in proportional chat server. It might be possible we would just had a 500 chat servers, right? So if we wouldn't have them kept separated, then we would have the 1000 chat server always. And if we increase the clients, number of a connection being increased, the load is being increased, we'll have to proportionally increase the chat servers, right? So hence that reason I just kept that on the separate socket handler machine, so that we can appropriately use that resources or machines, right? Okay. Now we are very clear. I've explained the flow of sending the messages. Client one is talking to the client two, right? Is there any doubt? Vishal, do you have any doubt on this part?
No, no, it's
Okay.
fine. It's fine.
Okay.
Clear.
Now let's just talk about let's just talk about how we will do the group chats as well also, right? So let's say there is a group of 1,000 people, and the client one is sending the message to the to in the group. So client one being connected into the socket handler one. If if it is a new connection, because it might be possible client one would have disconnected and again would have reconnected, the circuit handler one would update into the Redis cluster, their mapping. And if there is a not a new connection, existing connection, so it will not update into the Redis cluster. It will go to the any of the chat server, and then will persist that message into that particular group conversation table. And then Kafka will it will write into the Kafka, one of the Kafka partition. You may think, we may have the conversation ID as a partition key. So Kafka also has number of partitions for the parallel processing, right? So you can think of like in a parallel pipes in the Kafka, right? So when the CDC, the CDC is running on the database side, database server. It will write into the one of the partition of the Kafka, and again we can use the partition key as a message conversation ID, right? So given this conversation, when I say conversation, it means that group ID will have a one conversation ID. If we are talking one on one, then it will have a one conversation ID. The message ID will be different, but the conversation ID is being assigned at that group level, or the one-on-one level, right? So that using that conversation ID, we probably can partition the data in the Kafka as well, and we'll go to the one particular partition. Fan out service will read that message from the Kafka, one of the partitions. There will be an n number of fan out services here as well also, that is parallelly reading from the each partition of the Kafka, right? And each of the fan out service will talk to the group service will determine if that group has a 1,000 participant, it will return all of the 1,000 participant to the fan out service for that message. And a fan out service will send that message in parallel. It can send the message all of the 1,000 participant to the request handler will figure out whether the client is connected to any of the circuit handler. If it is not connected, it will it just that fire and forget, right? You fan out service just fire that message, and if the request handler doesn't find the client, maybe offline at that point of the time, so it will drop that message to that client, or those who are connected will receive the real time updates, right? And
So what if the person who is offline comes later online? Then is that
right.
someone will be continuously monitoring like whether this person comes online or not
No, so
for that particular message?
that case, so it's like in a push based mechanism. So that time client will have to pull the messages, whatever the message being sent to him, it will pull using the chat server from the NoSQL databases, right? uh, it's like in a pull based model at the real time when whoever is being connected receive the update, but those who is being offline at that point of the time will not receive the update. They will, once they connect it to an internet, they will receive an update, and the client will have a some mechanism at their side. They will pull from that, WebSocket, the chat servers, and will fetch all of the messages that has been sent to that person, right? So that's how it will be, uh, right? Now let's just talk about
So also one more thing, just a thing,
yeah.
like whenever client one sends a message, at what point of time will he be seeing the single tick, and at what point of time will he see the double
Okay.
tick? Like when it's written in the DB or when
Okay.
it's written in
I,
the Kafka, where it is.
Exact. That's a very good question. So client one has connected to the socket handler. Socket handler will send the message to the chat server one. Chat server has written the messages to the database, and it once that message is being received on the chat server one, or you can say, if you want to keep the very high reliability, but low performance. So you may probably send back the response probably after writing to the database, or probably once the chat server also receive. It is like a trade-off that you have to choose, like at what point you want to send back the response, right? uh, Chat server one, once the chat server one is received, it may send the acknowledgement back to the that particular client. Again, chat server will have to talk to the request handler, and it will send back that acknowledgement to the client one. Hey, I have received that message. Then it will give them a single tick, right? And once that, the message is being delivered. So let's say the message is sent, now the message is received by the chat server. We have seen the single tick. Now message, now once the message is delivered, how the two tick will appear, right? So so that communication, what will happen, so chat server once send write the message into the database, right? Send to the Kafka. Fan out service will deliver that message to the request handler. Request handler will connect to the socket handler. Socket handler will connect to the client too. And if the client too is connected at that point of the time, it will receive the message, and the client too will send back the acknowledgement as a message itself only, right? And that will flow back to the client one, that acknowledgement, to saying, giving them a double tick option, right? So because once the client to receive the message, the client too will send the acknowledgement as a message to one of the chat server, and uh, again it will probably write into the database, and then fan out service will redirect that acknowledgement to the client one.
So basically, acknowledgement is also kind of a message. Just
Exactly.
a type is acknowledgement, and same will go with blue tick also.
Right, right.
Okay.
Okay. Now we have talked about one-on-one chat. We have talked about the group chats. We have talked about the single tick, blue tick functionalities. I'll also talk about how we send that images and videos over the WhatsApp. So let's say, I mean, let's say I have to send the message, images to the client. One has to send the image to the client. So basically, it will again talk to the socket handler. Socket handlers, so this time it is not a chat server, because the type of a message probably it will connect to the media server behind the load balancer, and the media server will connect to the storage, and then the data, the bytes of that the image will streamed, and will be update into the S3. Once that it is updated into the S3, the media file is uploaded. Then it will return that, the file URL to the client side. Okay, this is the file URL being stubbed into the message that you are writing into that chat window, right? So so the file URL will go as a metadata as of the text messages. So let's say if there is some text you are writing after the as a part of that message image that you are sending to, or even if you are not sending any text, basically it is a two-step process. It's not a single step process. Once the image being uploaded, to the media storage, and that there will be a unique URL will be returned to you on to the client, and then you will press an enter. At that point of the time, it's sent as a message to the chat server, and chat server will store that all of that. But this time, the type of the message would be the media or image, so it will have that URL as well also be attached into the table, and but there will not be text. And if there would have been a text, it would have also gone as a part of the chat message to the NoSQL DB, right? So that had so every notification, everything that you're doing, even adding the people to the group, or or replying, or adding the new videos or images, are being treated as a chats only. But that happens as a two-step process. In case of the media, it upload first and return the unique URL, and that metadata is sent as a message to the chat server one, and it get updated into that. It I'll give that more clarity in the database design, so that you will understand in how that thing is happening. Okay.
So the WhatsApp is storing everything at their end, this media and all, or
Right. I mean, we can all, you can assume, as of now we have started key as WhatsApp is storing, but in ideal situation, WhatsApp doesn't store any of the messages at their side. It is like it is stored at your Google Drive locations, or it could be any of that. So basically, it allow you to connect to the your own Google Drive, and that is where you can save all of that messages. But we have started the version 1 of the WhatsApp, where the WhatsApp is also storing entire messages. We can have some flexibility. We may keep 30 days worth of our data, and then post that it will delete all of the entire data. We can also keep that option, right? But we can start with that, having all the data being stored, and then we can reduce, keep the time frame as a 30 days or 15 days or 1 week, right? So that will give an option users to store at their side, rather being relying on the WhatsApp to deliver their entire chat history and all, right?